So just to review the mapping rule, if I have the coordinates x, y on a function f of x, in order to find the corresponding point on the transformed function, so for example, g of x, what we would need to do is to find the value of the corresponding point on the y value. We multiply the value of y by a, and we will add c. Whereas for the value of x, we will multiply x by 1 over k, multiply the value of x, and we're talking about this x value here. So we're going to say x, and then we're going to say plus d. So if we look at an example and at the graph of this example, so let's say I have this function f of x. Let's use a parabola, and I have a point on the function, so the point 2, 4, and the parabola will undergo the following transformations. So a vertical stretch of factor 3, a reflection on the x-axis. It will undergo also a horizontal compression of factor 1 over 2. It will have a horizontal translation of 1 to the right and a vertical translation of 2 upwards. So if we apply all of these transformations to each point individually, that's where the mapping rule comes in handy. So if we apply the transformation, our transform graph will look like this. Let's see how we can figure out where this 2, 4 will end up as a mapping point. So for the following transformations, this point 2, 4 will become, or will map to which points? That's what I want to find. So let's look at this one at a time. So if I check out just the y, the factor in front of the y here, so we can call this one a. So this, if I multiply my value of x by a, so the x value that we're multiplying by a is, sorry, not the x value, but the y value is 4. So actually, oops. Okay, so let's change this to the correct value, which was 4. Okay, so I'm multiplying by 4 over here. So where did that 4 come from? It's the one that's in blue here. So we're multiplying this by minus 3. Let's look at the graph. So minus 3 times 4 is minus 12, yes? Now, if we observe over here, let's hide our final transformation here, and let's just quickly look at what happens if I do minus 3 times x squared. So if I do minus 3 times x squared, and I locate that point here, so I'm going to keep the fixed for now. I'm going to keep the fixed value of x and just put down the minus 12. Okay, what is this minus 12? It's here. Okay, so this is the mapped version of this coordinate 4. So I had 4. Now I have minus 12 because I've done two things. I've done a vertical reflection. Okay, so a reflection about the x-axis, and then I've done a vertical stretch of factor 3. So I've multiplied by 3. So this is now the version of the point. Let's go look now at the x value. So we're actually not finished with the y value, but we'll continue on after. So for now, let's go look at the x value. So for the x value, I have this k, which is my this k over here. So k, this means I will have this 2 over here. Okay, so what I want to do is I want to take my y value of, or my x value of 2, and I want to multiply that not by 2, but by 1 over 2. Okay, so I'm multiplying by 1 over k, the value of x. So that's going to give me 1. 1/2 times 2 is 1. So if you go back to the graph, so instead of the point 2 minus 12 now, so I'm going to type in, we found 1. minus 12. So for the fixed value of minus 12, what happened to the point? So that's the coordinate here. So if I take my function, now I've just done the next transformation, which was this multiplication factor of 2 here. So we can see that we've compressed the graph horizontally. And so the mapped point is now 1 minus 12. And then we can, in one last step, we'll do both of the next functions. So I'll hide this, this point now, seeing as it's no longer on my graph. So this is the mapped. Okay, and if we continue on, so I've taken care of A and K, and I'll take care of C and D. I'll just do it in one step here. So C or D, then C. So my vertical here. So here I see a minus 1. So what I'm going to go do for my mapped point is I'm going to add plus 1. So it's always the opposite sign for X. And so for my Y, I'm going to just say this plus 2. So I'm going to go and add that to my mapped coordinate. So it would be plus 2. Okay, so this is the mapping rule. This is what I'm applying here and here. Okay, so our final answer for the mapped coordinates of 2, 4 on the new fully transformed function will be 2 and minus 12 plus 2 minus 10. So if we go back and look at, so that's the final answer here for the mapped coordinates. So if we go look at the graph here, 2 minus 10, if I look at the final transformation, so it was actually already here. It's this one. So if you look at the point 2 minus 10, this is now the corresponding point. It's turned out to be here. Okay, so this will help us trace our graph.